Hello everyone, once again welcome to my channel. In this video I will be sharing the important thing of the MO class, MO theory. I have already mentioned and draw the diagram of O2, N2, O2 plus, all these things in my last MO class. If you have not watched, please have a look at that. Today I am going to discuss the important thing about the heteronuclear diatomic species. What are the bond orders, bond length, all these things. First of all, we need to know one thing, that is bond order and bond dissociation energy, that is also known as bond strength. Bond order and bond strength or bond dissociation energy is directly proportional. Why? Because you can apply common sense that if number of bonds are single bond, two atom has single bond, okay, then more amount of energy is required to break the bond. Or if two atoms have triple bond, then more amount of energy is required to break the bond. Obviously, the atom having triple bond. So bond order, as it increases, then bond dissociation energy also increases. Got my point? That is very much important thing to determine the order of some MCQs. Okay. And bond order and bond length, they are inversely proportional to each other. Bond order and bond length, they are inversely proportional to each other. Why? Because if between you and me attraction is there, attractive force is there, that means bond length will be shorter. More attractive force, that means shorter distance. But if bond length is higher, then attraction force or attractive force becomes weak, कम हो जाएगा. इसलिए bond length and bond order, they are inversely proportional to each other. Okay. So let's start the MO of some heteronuclear like HF, like CO, like Cn minus, all these things. NO. So this is energy, not in scale, y-axis energy, and you can see here, this is the atomic orbital of hydrogen, 1s orbital is there, 1s1, you know, HF, and fluorine 2s2 atomic orbital of fluorine 2s2 is there. Why this mismatch occurs? Because fluorine is more electronegative element. And remember, as the electronegativity of the element increases, that means the orbital will be more closer to the nucleus. So 2s of fluorine is much lower energy as compared to the 1s of hydrogen. Am I clear? Okay. So if beryllium is there, then 2s would be like that. If lithium is there, then 2s would be like that. But as oxygen, nitrogen, fluorine, carbon, they are more electronegative than nitrogen. That is why their atomic orbital will be in lower energy. I hope you got it. Now come to this part. That is our 2p part. fluorine 2p part px, py, pz. Look at that. That fluorine is 2p5, you know. Fluorine, remember the configuration 1s2, 2s2, 2p5. 1s2, 2s2, 2p5. Okay. So this 1s and this 2s, I have told you in my last MO video. If you have not watched, please have a look at that, where I have told you that for the formation of bonding, 3 criteria are to be matched. One is energy, another one is symmetry, another one is direction. So this is a great mismatch of orbitals. That is why this 2s of fluorine is not going to form bond with this 1s. Got it? So this 2s will be like a non-bonding electrons. This will be like a remaining non-bonding electrons. So this is non-bonded, no bonding is there. Now this px, if again x-axis is being considered as bonding axis, then 1s and its px will form sigma. So will form sigma, fine. And obviously it will have anti-bonding. So this is sigma star, this is sigma. No problem with that. Now this is S and 2px. This is S and 2px. S and 2px. Now I am attaching this because this molecular orbital is formed between the combination of these two. Okay, but the remaining two are forming non-bonding electrons, because already this px and this 1s is involved, isn't it? That is why this py, pz remaining as non-bonding electrons, और कोई ऑर्बिटल और इलेक्ट्रॉन नहीं बचा है बॉन्डिंग के लिए. Got it? So now this 5 and this 1, total electron is 6. Put it here, 1, 2, 3, 4, 5, 6. Got my point? So how many lone pairs you can see? You can see 1 lone pair, you can see 2 lone pair, you can see 3 lone pair. And there is no electron in anti-bonding because all the 6 electrons are filled up here. So BO will be number of bonding electrons minus anti-bonding electrons divided by 2. That is why bonding electron 2 minus 0 divided by, there is no anti-bonding, so 1. So H F के बीच कितना bond बनता है? 1. Only 1. And the lone pairs, you can see that this is the lone pair. This one, this one, not this one, sorry. This one lone pair, this one lone pair, this one lone pair. They are not taking part in chemical bonding. Got it? So this is the MO of HF. Now come to the CO part. CO, carbon monoxide. We will see what is the bond order in between them. So now come to the CO part. CO part means carbon and oxygen, 2 atoms are there. Okay. But the 2s of oxygen will be slightly lower than the 2s of carbon. Why? Because I have told you that more electronegative element, that means lower will be its energy orbitals. Its orbitals, 2s, 2p, that will be lower. So let us start. Carbon monoxide, carbon is 1s2 2s2 2p2 and oxygen is 1s2 2s2 2p4. So say for example this is 2s of carbon, 2s of carbon, 2s2 and 2p2, okay, 2s2 2p2. Now oxygen will be slightly lower, 2s of oxygen will be slightly lower, atomic orbital of oxygen 1s. I am repeatedly saying you that 1s is not been considered here because valence shell, only valence shell portion is being considered. Got it? So 2p of oxygen is also lower as it is more electronegative than carbon. Okay? Now these 2s, energy mismatch, but still it can form bond because not so much energy mismatch like HF, like the previous one. So here sigma bonding and sigma 2s anti-bonding will be there. We need to join this. Okay, and we need to remember that the bonding portion will be towards in oxygen and the anti-bonding portion towards with respect to carbon, as oxygen is more electronegative in nature. Now 2 2, so electrons are to be filled up here, no problem with that. Px will form sigma, again x-axis is the bonding axis, same, but here again pi 2py, pi 2pz, sigma 2px, and anti-bonding sigma 2px star, pi 2py star, pi 2pz star, because of this sp mixing again like nitrogen, which I have discussed in the video of homonuclear diatomic molecule. sp mixing should be there, and sp mixing, due to this sp mixing, sigma energy will slightly be higher. So now these orbitals we need to join. As simple as that. Then 4 and 2 total electrons are 6. So here 1, 2, 3, 4, 5, 6. So this is occupied, but this energy is higher. That's why it is called highest occupied molecular orbital or HOMO. Highest occupied molecular orbital or HOMO. Okay. And LUMO is this one. This is also unoccupied, this is also unoccupied, but this one is LUMO as it is lowest unoccupied molecular orbital. Already I have all this explained in the last video. So in the highest occupied molecular orbital, you can see that electrons are paired. That is why CO is diamagnetic in nature. Okay. And bond order, what is the bond order? Bonding electron how much? 2, 4, 6, 8. So 8 minus number of anti-bonding electrons 2 divided by 2, now it becomes 3. So that's why carbon monoxide, the bond order is like that. कार्बन नॉर्मल कितना बॉन्ड फॉर्म कर सकता है 4, लेकिन यहाँ पर 3 है इसलिए माइनस, और ऑक्सीजन देखो नॉर्मल बॉन्ड कर सकता है 2, लेकिन यहाँ पर 3 इसलिए प्लस. आई होप इट इज क्लियर. सो व्हेन some electron donation will be there, then sigma electrons will be donated. So electron will be donated from this sigma when donation of electron, scope of donation of electron is there. And if electron acceptance is there, if it has a scope to accept electron, that means electron will be accepted in this vacant antibonding orbitals. That's why in the coordination chemistry, I have told you that in my VBT class, in the video valence bond theory, carbon monoxide, Cn minus, ethylene diamine, all these are strong field ligand. Why? Because sigma donor and they are pi acceptor. If you are sigma donor and pi acceptor, that means you are a strong field ligand. You have that ability to pair the electrons of the central metal atom. Okay, so this is related, if you know this is related to coordination chemistry also. Okay, so bond order, magnetic nature, all these are clear to you. So CO is completed. If you have any question, then let me know in the comment section. Clear? Now come to, and you can ask me that how can you say understand? sp mixing will be there because C6, oxygen 8, so total electron is 14, and I have told you that if number of electron is 14 or less than that, then sp mixing will be there due to this short distance of 2s and 2p. That's why this bond energy is reversed. Oxygen is normal case, nitrogen is abnormal case, and all these are similar to MO of N2. Okay. Now come to NO part. NO. PX, PY, PZ, 2S, AO of nitrogen, NO, nitrogen is 1:2:2p3, and oxygen 2S, AO of O, and this is 2p, AO of O. Okay, got it? So again 2s2 2p4. So 1s is, I am not showing here. Now again 2s star bonding. Let us join this. No problem with that. And again PX forming sigma 2px pi, py pi, pz pi, but that is normal case because oxygen has the electron 8, nitrogen has the electron 7, so together will become 15, so it is greater than 14, so sp mixing will not be there. sp mixing के लिए इलेक्ट्रॉन नंबर 14 या 14 के लेस होना चाहिए. Got it? Now This is like total our normal case. So pi 2p y star, pi 2p z star. So we need to join this and fill the electron 4, 3, 7. So that's why nitrogen 2s2 to p3, oxygen 2s2 to p4. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4 plus 3, 7. So if someone is asking that NO plus, what is the nature? NO plus, this is NO. NO plus को हटा दो, तो यहाँ पर क्या होगा? NO plus के लिए ये इलेक्ट्रॉन नहीं रहेगा और तब वो जाके हो जाएगा डायमैग्नेटिक इन नेचर. But normal NO, it is paramagnetic in nature. Got it? You will get the bond order easily, so I am not showing. So like this, we need to draw Cn minus also, and I will explain why it is again strong field ligand, because it is sigma donor, you will observe it, and pi acceptor. I am now drawing Cn minus, so carbon and nitrogen. So carbon 2s, 2p, px, py, pz, atomic orbital of carbon is there, and this is 2s of किसका है? नाइट्रोजन का है 2p, 2p3. Okay, so again Cn minus, that means nitrogen is 7, carbon is 6, 7 plus 6, 13, 1 minus, so total electron is 14. That means again sp mixing will be there like our nitrogen, like our CO. So bonding, anti-bonding, sigma 2s, sigma 2s star, all these I am showing, 2, 2, 4, okay. So px again I am considering bonding axis, x axis is the bonding axis, you can consider whatever among these three. So अगर z को bonding axis पकड़ोगे तो pz will form sigma, मैंने x को पकड़ा है इसलिए px will form sigma. तो यहाँ पर भी क्या होगा, अब तो जान चुके हैं हम, सिग्मा will be ऊपर जाएगा और पाई नीचे आएगा, because it is the case of sp mixing, short 2s 2p distance, and anti-bonding will be here, not affected, pi 2py, pi 2pz. So these are joined together. Here, and you will get 3 plus 2, कितना इलेक्ट्रॉन रहेगा? 5. So यहाँ पर 1, 2, 3, 4, 5, और यहाँ पर एक माइनस भी है, Cn माइनस है, that's why another electron should be there. This electron comes from where? This electron comes from the Cn minus. Okay, so this is homo, occupied, but this is highest occupied, so this orbital is homo, sigma 2px, I mentioned earlier, this is homo. and this is LUMO. और अगर तुम बॉन्ड ऑर्डर कैलकुलेट करोगे तो यहाँ पर 2 2 जा 4 6 8 minus 2 by 2 8 minus 2 by 2 कितना होता है 3. So that's why CN के ऊपर बॉन्ड रहेगा, बॉन्ड ऑर्डर कितना होगा 3. 1 sigma 2 pi. Magnetic behavior diamagnetic. And again you can see that this is sigma donor and pi acceptor. If electron is to be accepted, then it has to be accepted in this part. So Cn minus is again strong field ligand. Okay, so I hope you got it. The homonuclear diatomic MO in one of my videos, and this is heteronuclear portion I have explained. But without MO, without drawing this MO in competitive exam, without drawing this MO, we can answer some question by applying the trick. If you follow this trick, I hope there will not be a problem. I will discuss my question answer in my next video session of MO. Okay. ये याद रखना है, अगर number of electron 14 होगा, if number of electron is 14, then bond order will be 3. Number of electrons if 14, then bond order will be 3. We have to remember this. Okay. And just if number of electron जितना कम होगा, मतलब 13 होगा, so it will be 2.5. 14, 12, it will be 2. 11, it will be 1.5. 10, it will be 1. And mirror image will be observed. This portion mirror image will be observed. So that's why okay. So O2 का bond order कितना 2. From MO theory I have determined. Please see that video. Homonuclear diatomic. Clear? So यहाँ पर O2 का मतलब क्या है 16 electrons 8 plus 8, तो bond order will be 2. N2 plus कितना होगा N2 plus N2 N plus N 14, N2 के बीच bond order कितना 3, but N2 plus that means it would be 2.5. Okay, so I hope it is clear. And bond order and bond strength directly proportional, bond order and bond length inversely proportional. Clear? I will upload some videos of this bond length, bond order in my next session. I hope you like it. So don't forget to share, like and subscribe. If you haven't subscribed yet, please subscribe to my channel and let me know the feedback, and if you have any query in the comment section. Thank you. Have a good day.